Good day, everyone, and once again we're back together, just looking at the 2023 exam. So this is the May exam for supplementary exams that were written in May. So if you haven't subscribed, please just make sure that you're part of the family, and of course you can join as a member in this channel. Okay, and you can actually get the details on the description that is below. All right, so let's get into functions, right? So I'd like to first apologize for the poor visibility of this question paper. All right, it has been scanned, but but I'm sure that you can actually just pick up what is happening. Right, so let's get into it. So we've got the graph of f of x, which is minus x plus 3 squared plus 4. Okay, so I'm just going to write that down. So we've got f of x, which is minus x plus 3 squared plus 4. Now, we know that if you are given a parabola in this manner, so it means that they've already given you the coordinates of the turning point. So you know that our turning point in this case would be at negative 3 as well as at 4, right? So all you simply do, it means that you take this value here and that value there. That becomes the x value of your turning point in this case, but you need to remember to change the sign, and that becomes the y value of your turning point, but you keep the sign the same. Right, now let's look at what they are asking us. We also have g of x, which is x plus 5. Okay, so we just need to keep that in mind. That's x plus 5. Okay, that's equal to x plus 5. Right, so that is the linear function, okay? And of course, they are meeting or intersecting at A and B, right? They do tell us that. Now, let's answer 5.1. So 5.1, they said to us we should write down the coordinates of the turning point. Well, actually, we've just answered that. And you see how they said write them down? So it does suggest that they're sitting right in front of you. So in this case, that would be negative 3 and 4, right? Right, so the next question, they say write down the range of f. Now, remember, if we're looking at the graph of f, it starts all the way from negative infinity, right? In terms, remember, when we're talking about the range, this is where the graph exists, in terms of the y values. So for the y values, all the way from negative infinity, and what would be the maximum value at the turning point, right, where y is equal to 4. So in terms of the range, we would just simply say y is an element of negative infinity, okay, and all the way up until y is equal to 4, and we include that value because it is part of our range, right? Alternatively, you can write this as y is less than or equal to 4, right? So in this case, this would be our range. Right, and then they say to us, show that the coordinates of A and B are negative 5 and negative 2 respectively. Now remember, A and B, this is the intersection of the two graphs. Okay, so, all right, let's make some space there. So where do the two graphs intersect? So this is where f of x is equal to g of x. All right, I'm going to make some space there. Right, so this is where this is minus x plus 3 squared plus 4 is equal to x plus 5. Now let's try and solve as much as we possibly can. Okay, so we have got, okay, so that's going to be x squared plus 6x plus 9. Okay, this is plus 4, which is equal to x plus 5. All right, let's try and make this as quick as possible. So I'm going to take everything here to the other side. And of course, when we do that, I'm going to take it as a group. the negative will actually move away. So I will have 0 on this side, which is equal to x squared plus 6x plus 9. Okay, so if I take the 4 to the other side, it becomes negative. So I'll have plus x plus 5 minus 4. And remember, all of this is equal to 0, which is over there. Right. So a quadratic equation looks something like this. X squared. Okay, so there are our x terms. So that's 6x plus x, which is 7x. All right, and then we've got 9 plus 5, which is 14, minus 4, that would give us plus 10. All right, so this is equal to 0. Now, ladies and gents, what we need to do is factorize. So we're looking for factors of 10, such that when we add them, give us 7. All right, goes without saying that's going to be 5 and 2. Okay, and it tells us that the brackets are definitely the same, or rather the signs inside the brackets are the same. Okay, so in this case, we've got x is equal to negative 5, or x is equal to negative 2, right? So definitely, we know that negative 5 would definitely be associated with A, right? And negative 2 with B. Now, they did say the x coordinates. What we would have done to find the coordinates, I mean, we know at A, that would be negative 5 and 0. And at B, that's negative 2. Now, in this case, to find the y value, we would just substitute into any of the two equations. So, for instance, we'd say g of negative 2, that would be negative 2 plus 5, which is equal to 3, right? So the y value would be 3 there. However, they did not ask for the y values. So in this case, we've proven exactly what they wanted us to prove. Right, now let's go on to the next question. Now, they say to us, hence, determine the values of C for which the equation, all right, now look at this, that equation there, somewhat, I mean, if you think about it, it somewhat resembles a parabola, doesn't it? The only difference is that we now have that C there, and this also resembles, the linear function, the straight line, right? So we want to know how will we shift, by how much will we shift the graph, okay, such that the equation, all right, this and that, have got one negative value and one positive root. Okay, so we want to know, right? Okay, I want us to go back to the graph. Remember, right now, A and B are both on the negative side. Okay, so what I want them to be is I want the one value to be on the negative side and the other value to be on the positive side. So, right, now given that this value, we found it at negative 2, right? So that this value is on the on the positive side, how much would I have to shift the graph? I'd have to shift it 2 units to the right, okay? Right? So in this case, I would have to have my C value to be 2 units to the right. And remember, when I'm shifting towards the right, in this case, I must make sure that, so that would be minus 2. Remember, when I want to shift to the right, in terms of x values, right, I'd say minus 2, right? Now, I want you to note, however, if I keep shifting the graph, and this is the part that you need to be careful, I need to make sure that I don't shift it such that this value ends up on the other side, okay? So what would be the other limit? Is that in this case, I mustn't shift the graph so much. Now remember, this is negative 5, right? So yes, I can shift it between 2 units, but I must not shift it beyond C is equal to 5 units, right? So that means that my C value, right, has to be between 2 as well as 5 units. I hope that makes sense, ladies and gents, so that the two values don't now become both positive. Okay, right, I hope that makes sense. So for 5.4, and that is why they said hence, right? So C must be an element of, right, -2. So it means that I can shift the graph by 2 units to the left. Okay, so we said that should be -2 and -5. Oh, actually, I shouldn't include those values because it wouldn't be positive. It would be 0 at that point, right? So it must be between 0 and 5. Or you can say C must be less than or equal to -5 and greater, actually greater than -2 and less than -5. Okay, right, I hope that makes sense, ladies and gents. Right, so the last question. Okay, so they say to us, the maximum distance between F and G, okay, so between on the interval X is greater than A and B, less than B, right? So they say the maximum distance is K, right? So they say if hx is equal to g of x plus k, determine, right, h of x, right, in the form h of x is equal to, right? Now remember, so we want to find out first what is that maximum value of k. Right, now I want you to note between A and B, right, we want the maximum distance between the two graphs. Okay, so let's try and indicate it there. So we want the distance, the maximum distance between these two graphs here, right? So that will be the equation of the parabola minus the equation of the straight line. That's the distance between them, isn't it? Okay, so the y value of the parabola minus the y value of the of our straight line, and then what we'll do is that we'll try to maximize. Okay, right, so we're going to say, right, so let's say in this case, so we're trying to find the distance. Okay, so the distance in terms of x will be equal to the parabola, so f of x minus g of x. Okay, g of x. Right, so in this case, my f of x, remember this was, so that's minus x plus 2 squared plus 5, plus 4 rather, okay, and that's minus, in this case, x plus 5. Okay, so that's our straight line. Please remember that that is what we did there, right? So we took the parabola minus the straight line, in this case, to find that distance formula. Right, so what we're going to do is, try to work out there. I think, did we not find something between those two? Yeah, I think if we work it out, we're going to get exactly that over there. All right, so we've already done so. We said, okay, so that's minus x squared minus 4x minus 4. Okay, all right, so this is going to be plus 4 minus x minus 5. Okay, I hope I'm correct there. So that's minus x squared. Okay, so that was minus 5x. Okay, so that's minus 4x minus 5. Okay, that and that cancel. Okay, and we've got minus 5. Okay, let me just check if I've done the right thing there. I know I ended up on the other one with plus 10. Okay, please let me know if there's, oh yeah, I said x plus 2 instead of x plus 3. Sorry about that. So this is going to be x plus 3 rather. So that becomes 6x. So that's minus 6x. Okay, and minus 9. Apologies about that. So that is plus 4. Okay, minus x minus 5. Okay, let's try and rework that again. So that's minus x squared. Okay, so that's minus 6x minus x. That's minus 7x. Okay, apologies there. And so that gives us minus 9 plus 4, which is negative 5 minus 5. So that's minus 10. Right, there we have it. So this is the distance, okay, of x. Right, now they said to us we need to find the maximum distance. Right, now remember, where is it maximum in this case? Right, so they said to us k, right, is that maximum distance between the two. Okay, now where would it be maximum? Okay, so it would be maximum in this case. So for any graph, you can say whether you take the derivative and make it equal to 0, or you can say x is minus b over 2a. Right, so the distance of x, right, is maximum at the derivative, right? When we make the derivative, make it equal to 0. So that will be minus 2x minus 7 is equal to 0. So that will be negative 2x is equal to 7. And if we divide by negative 2, in this case, what we get is x is minus 7 over 2, right? Now, then what is that maximum distance, right? So that maximum distance, which they called k, by the way, and I could have actually called it, k of x. So that's minus 7 over 2, okay? D of minus 7 over 2, which is equal to negative 7 over 2 squared, okay, minus 7, negative 7 over 2 minus 10. Okay, right, so let's try and work that out quickly. Right, so we've got that's negative 7 over 2 over 2. Okay, and we need to square that. Squared minus 7 into negative 7 over 2. Okay, and we said minus 10, right? So that's minus 10. Okay, so I get a value of 9 over 4 as my final value. So which means that the maximum distance, okay, between the two, okay, so we said when d is negative 7 over 2, okay, we get a value, the maximum distance therefore becomes 9 over 2. Now remember, they said to us we need to write h of x, right, which is equal to g of x plus k. So h of x is equal to, now remember, g is the straight line function, right, which is x plus 5. Okay, so that's x plus 5, which is our straight line. Okay, plus 5. And we said plus the k value, so that's plus 9 over 4. So what we have there is x plus 5. 5 plus 9 over 4, we can work that out on our calculator. Okay, we still had that 9 over 4 there. Okay, 9 over 4, we can say plus 5, and that gives us 29 over 4, or you can say 7.25. Okay, so that's going to be 29 over 4. Okay, so that is h of x. All right, please remember how we could have also done this here is just simply to say, well, minus b. So to get the x value at the maximum point, okay, we would say minus b over 2a, just like you would when you're finding the turning point. So that's minus a negative 7 divided by 2 times a negative 1. And you could have also gotten the very same value, which would be 7 divided by negative 2, which is the same as negative 7 over 2. Okay, so you can go either this route, but the fact of the matter is that once we're done with that, we can go and substitute to get the maximum distance. All right, please remember, this would be the maximum distance there. All right, I hope that makes sense, ladies and gents. And essentially, we are done with this question, and that is essentially how the cookie crumbles. All right, so I hope that you'll be able to look at the next question, right? And please don't forget to subscribe and like, and I'll see you guys next time. Shop, shop.